Hi, this screencast is about base units in the metric system and prefixes. So I know in the United States we use units such as gallons and ounces and so forth for liquids and pounds and ounces for weight, but in science we use the International System of Units, or the SI system, or the metric system. So that's what we're going to talk about today. The base units in the metric system are meters for length, kilograms for mass, although we use grams in labs, seconds for time, Kelvin for temperature, and mole for amount of a substance. So most of these you're probably familiar with. If I had to take a guess, I would say you may not be as familiar with the Kelvin scale, and we'll get into that shortly, or mole. Mole, as the amount of a substance, is a unit that's used expressly in chemistry. So that is also something that we will be talking about in more detail in future chapters. So for right now, let's just focus on meters, kilograms, seconds, and Kelvin. The SI base units for mass are kilograms, as we said. Mass is a measure of the quantity of matter, and while we use grams in class and labs, the standard unit is technically kilograms. Please make sure you understand that mass is not the same as weight. Weight is actually a measure of the gravitational pull on matter. So in chemistry, we kind of use the terms mass and weight interchangeably, but when you get to physics, you will find that mass and weight are not the same thing. They're very different things. And so this difference of the gravitational pull on matter really makes a big difference once you get to physics. So just make sure you're aware of that. The base unit for length, as we mentioned before, is meter. Sometimes kilometer is used. The abbreviation for that is km when there's a longer distance. When we're talking about shorter distances, we may use centimeters or millimeters. So what is the deal with these metric prefixes? Well, each prefix represents a position of the decimal, and the metric system is based on a unit of 10. So each time you move one spot, you're talking about a factor of 10. So for example, here's our base unit of liter, gram, and meter. When we move to a decameter, that's 10 times larger. A hectometer is 10 times larger than a decameter, or 100 times larger than a meter. And a kilometer is 10 times larger than a hectometer, or 1,000 times larger than a meter. This also works the same way as we get smaller. A gram is one base unit. A decigram is 10 times smaller than a gram. A centigram is 10 times smaller than a decigram, or 100 times smaller than a gram. And a milligram is 10 times smaller than a centimeter, or 1,000 times smaller than the gram. So the way these metric prefixes work is based on this unit of 10. To list your metric prefixes in order, you may remember the saying, King Henry died belly up drinking chocolate milk, and that will help you get these prefixes in order from largest, kilo, to smallest, milli. You will need to memorize the relationship between the base unit and the prefixes for kilo, centa, and milli for your test. There are other prefixes. We talk about gigabytes and stuff like that, megabytes, but those are not going to be used on the test. They're used less often, and you don't have to memorize them. So let's practice moving decimals. Let's say you measure the table to be 59 centimeters. What is the value in meters, and what is the value in millimeters? Well, to change from centimeters to meters, you're going to have to move the decimal place 2 times. And we're making the unit smaller, so we're going to move the decimal point 2 places to the left. So it becomes 0.59 meters. If we're going to go from centimeters to millimeters, that's only one slot over on our scale, so we're only moving one place, but we're moving to the right, so our decimal point moves one place to the right. So 59 centimeters becomes 590 millimeters. For temperature conversions, as I mentioned before, we'll be using the Kelvin scale. Units that we'll use in class, we oftentimes make measurements in Celsius, but we have to use Kelvin for converting. Kelvin is an absolute temperature scale. This means that there are no negative temperatures. So while you can have a negative temperature in degrees Celsius or a negative temperature in degrees Fahrenheit, in Kelvin the lowest possible temperature is 0. And this is important because you can't use 0 in computations, and nothing actually gets that cold. So think any number multiplied by 0 or any number divided by 0 is 0. So when you're doing calculations, you can't have that number. So by using the Kelvin scale, we eliminate that problem in doing computations. So how do I convert? Kelvin equals Celsius plus 273. So right here, that should be an equal sign, not a plus sign. So for example, if you have 25 degrees Celsius and you want to convert that to Kelvin, you take your temperature in degrees Celsius, 25, you add 273 to it, and you get a temperature of 298 Kelvin. Please also note that this is not degrees Kelvin, it's just Kelvin. Okay, so again, your conversion factor to convert from degrees Celsius to Kelvin is to add 273. Likewise, if you were given a temperature in Kelvin and you wanted to convert it back to degrees Celsius, then you would subtract 273. At the bottom of your notes, please complete these practice problems. Make sure you show your work and turn them in with your notes to Mrs. Benke.